Hello, my name's Kent McVay. I work at the Southern Ag Research Center. I'm going to talk to you a little bit about water use efficiency, a study that we have here this summer at the Research Center. So water use efficiency can be defined a couple of different ways, but for purposes of this study, it's really the yield you get, the increased yield you get per increase water use. And so think of it in terms of pounds per acre per inch of water. If you have a 12-inch precip year and you have a certain yield, if you get a 13-inch precip year, how much gain do you get? And it's going to vary by crop. It's probably also going to vary by the timing of when that water comes. But it's easy to calculate. You just need to get grain yield. We get that from plot harvesting at the end of the season. And then you need to total up the precipitation that occurred during that period. And so in a semi-arid environment like this, where we don't have any significant runoff and our precipitation usually is small enough that it all goes into the soil in place where it falls, you can just total up precipitation and then do a water balance on the soil. So sample at planting time and at harvest, and then calculate the difference in available water between those amounts, so you can correct for the water that came from the sky and what came from the soil. And if you add irrigation to it, then you need to add that amount in as well. This is a study I'm going to show you from Akron, Colorado. It was taken about 20 years ago by Dr. David Nielsen, and he did peas, lentils, and chickpeas. And basically on the x-axis it's water use, and on the y-axis is grain yield. And so as you increase water intake by the crop, grain yield goes up in these kind of environments. And so the water use efficiency is basically the slope of that line. So for chickpeas here on the right, it has the highest slope of any of these crops. And so you get higher water use efficiency for chickpea than for peas, and lentils are the lowest. But convert that to English units, pounds per acre inch. This data from Colorado is from that chart, 240 pounds per acre inch of water for chickpeas. There's other locations that have got data that are near Montana. So one from Alberta I found is around 188 pounds. And so, you maybe could average those to get an estimate of what we should be expecting for chickpeas in Montana. So we haven't really measured that in Montana. So that's kind of the purpose of the study, is to try and get a measure of what we can expect. Spring peas are a little bit less, around 180. Lentils are anywhere from 75 to 130, depending on source. So let's compare that to crops we typically grow, like spring wheat, winter wheat, and barley. So spring wheat's around 260, winter wheat's around 280, barley around 330 pounds per acre per inch of water. So all these legume crops, these pulse crops, are less than what we see for these grass crops. And you think about those grass crops compared to a warm season grass like grain sorghum or corn, they're quite a bit less as well, because grain sorghum is around 684, it says here from data from Colorado, and corn is around 511. So that's kind of the range of values you can expect for Montana. This study is to try and nail that down a little bit closer to what we're doing. We have this study here at Huntley. It's also been repeated in Sydney, Montana by Chensi Chen and his group. So the study that Nielsen did was designed like this. He used impact sprinklers. So these white dots are the 6 impact sprinklers. A fully irrigated center plot gives you fully irrigated rate, and as you move away from one of those lines, you get less and less water to where you actually get outside the reach of those sprinklers. You have rain-fed plots. So he had 4 rates, and then the black dots indicate where he did soil water balance, and also where he measured irrigation catch to quantify how much water he put on. It's a good design. You need a bigger area to do it. One of the problems with it statistically is that you always have the fully irrigated in the center. And so if there's any reason, it's just not as randomized as it could be. So if you did it we decided to lay it out a different way and use drip irrigation as our source rather than us impact sprinklers. And so in this case, across a rep, I can have a completely randomized design. And so it's a randomized block design. So we have 2 varieties and 4 water treatments. So there's 8 plots per rep. Water comes from a well through a filter, and then we have 3 valves, 1 for each rate. And so we've got drip lines, 2 sets of drip lines on each one of these lines. So I can open up a valve and irrigate a rep or all 4 reps at one time for 1 treatment. So here we are at the water use efficiency study. This is the line coming in from the well, which is right over there. And it unhooked, but it comes in here, and then you can see the valve set up there. And then there's 4 lines going into each plot. 1 plot, you can see right down here, has no lines going into it, so that's a rain-fed plot. There's 2 varieties. I think the varieties are CDC Leader and Royal. So the Fernleaf one is Leader, and the Unileaf is Royal. We've had a little bit of disease issue with Ascochyta, so this has been sprayed 2, maybe 3 times now with fungicide to keep them disease clean. You see basically there's not much difference in height at this point, and we're just past flowering stage. So it's pretty much set, especially with this 2-inch rain we just got yesterday. These are the peas, same setup, 8 plots. We have 4 different water rates, rain-fed rate, and then add around 1, 2, and 3 inches of precip through the drip irrigation system. The peas are Admiral and CDC Saffron, and they're just at the end of the flowering, the last flowering, I'd say. And so that's pretty much set too with this last rainfall we had. And then as a comparison, I think for water use efficiency, I think it'd be really important to have wheat. So we added at this location 1 more with wheat, and it's just 1 variety, Egan spring wheat variety. So we'll have that, and the last one plot here, you see there's no drip line, so that means it's the rain fed. Not much height difference. We could see some height differences earlier on with peas, because I started irrigating before flowering. I think it was May 29th was the first irrigation, then June 19th, and then June 26th. And today's June 30th, and we had a 2-inch rain on the 28th to the 29th. So that's the study for now. Well, when we first started this study, we were hoping for a drier than normal year to maybe a normal year, because in a really wet year, differences due to water are usually washed out and you don't see the response. 2018 was the first year we did this study, and we just did it on peas the first 2 years. And this is a graph showing the normal precipitation here at Southern Ag Research Center from 1st of April to the end of July. 9.3 inches of rain is a 30-year average. But you can see we had way more rain than that in 2018, 15.3 inches over the season. So it's not surprising when you look at the data, there was no difference due to treatment for our irrigation treatments. We got the same yield at rain-fed as we got when we added 3.6 inches of additional water, and no difference due to variety. An early and a late maturing varieties basically yielded the same. Hopeful for 2019, it was a little bit more normal, but then it got wetter towards June and first part of July, and we ended up with 10.7 inches over that period, which 9.11 would have been the normal. And yields were a little bit better than they were the year before, probably a more timely rainfall, but no difference due to treatment. So we're hopeful this year that we'll see some differences, and it's been a drier than normal year. So up until just here at the end of June, we've got this last rainfall that filled the profile. Probably are done irrigating for this study. I got all my treatments on ahead of time. We did see some height differences in peas, maybe some differences in chickpeas, I could not see any differences in wheat, although the check, I have border strips out there, and the border strips of the peas are definitely shorter than where they didn't get irrigated than where we do have irrigation treatments. So we're hopeful that we'll see some differences, but we'll stick with it and see how it goes. Again, we have a second site at Sydney, so if I don't see differences here, maybe Chelsea will see them there at Sydney. And so it should be a good study over the next 3 years that we do it. So thank you for watching, and we'll see you later.